All right, we're going to look at ozone depletion, which is covering topics 9.1 and 9.2. 9.1 is just all about the ozone layer in the stratosphere, why it's important, and it's important for our health and for life on Earth. And then 9.2 is the anthropogenic factors that are ruining the ozone layer and creating that ozone hole. Okay, so just a little review. Recall that the gases in our atmosphere are as such. The nitrogen levels about 78%, oxygen around 20, and then we have some miscellaneous other gases that are naturally here, including some greenhouse gases, but all here due to nature. This is all before us. Okay, so a quick review. Do you remember the layers of the atmosphere? The bottom one. Try the spaghetti and meatballs. They're excellent. So TR, troposphere. Try the spaghetti. The stratosphere has the ozone layer. The meatballs is the mesosphere. They are excellent for the exosphere, if that helps you. If it doesn't, here it is. So just remember each layer changes with amount of gases and temperatures. So the troposphere gets cooler. The stratosphere gets warmer. The mesosphere gets cooler, and the thermosphere gets warmer, so it alternates. And also remember, this is where life is. All the gases we just talked about, the nitrogen, the oxygen, and all the others. Stratosphere is where the ozone layer is, and the mesosphere is where the meteors get broken up. And then this is the thermosphere, where we have the interaction between the Earth's magnetosphere and the sun's solar winds, and we get those aurora borealises. I spelled that wrong, but you know what I meant to say. But we're going to focus just on the stratosphere. And so to do that, let me get rid of what I was writing. Oh, I lost my little thing. Boo. Anyway, we are going to look just at this ozone layer right here, O3. And let me fix this so I don't like looking at all of it. Okay, we're going to look just at this ozone layer, O3. Remember, this is where the good ozone layer is, and this is where the bad ozone is, down here in the troposphere. And remember, this one is caused by pollution from cars, secondary pollution, reacting with sunlight, the NOxes and the SOxes and all that. Okay, just remember. Okay, so the ozone layer forms through this naturally occurring ozone cycle. And so it's important to realize we've got this O2 molecule. Oxygen exists as a diatomic molecule, so O2. You always see O2. And then in the stratosphere, sunlight, UV light, will interact with it to break it up into a monoatomic molecule, so just plain O. It'll split into O and another O from this O2. This is not a naturally stable thing because oxygen only has 6 little buddies out here. Usually it's drawn like this, and so it's always looking for 2 more. And so if it's diatomic, then at least it's able to share 2, and that's why it's a more stable existence. It's sharing as a covalent bond right there. It's sharing what's happening. Anyway, that's a chemistry refresh. All right, so we've got these diatomic oxygen molecules splitting to monatomic, and so we have a lonely oxygen molecule that actually finds another diatomic molecule of oxygen, and it becomes ozone, a triatomic, O3. Ozone is not super prevalent in the atmosphere. It doesn't stay for a long time, so this is actually a reversible cycle reaction, and so it's constantly moving back and forth, and it's dependent on a lot of things like temperature and time of year, how fast or slow this reaction forms. Now, we should know by now the job of the ozone layer in the stratosphere is to block these UV rays, particularly UVC for cancer, but the UVB, some of it does get through. UVB also can cause cancer. What kind of cancer? Skin cancer only. Don't just put cancer, you won't get credit. So we let the UVA in and a bit of the UVB, and we totally block out the UVC. These are the more harmful wavelengths, so it's good that they are blocked out. And then this graphic down here just reminds you that this ozone down here came from this and not the sun, factories and exhaust and the NOx component of things. Okay, so why do we need UV light? What are the necessities of it? Why can't we just block all of it out? Well, it provides and creates this vitamin D for us, and that helps us with our ability to stay healthy. It helps us with our immune system. So it's a little immune system boost. You might notice that vitamin D is added to things like milk and cereals. It also helps us with our mood. It actually improves our mood to be out there around 10 minutes a day of sunlight absorbing. Obviously, it's a photosynthesis component, so we need that for our glucose, which is food, and the oxygen production that plants do as a result of their photosynthesis, because without that, there's no other life. And it's just part of that oxygen cycle that we looked at earlier. So it's necessary. Okay, so what takes the ozone layer away? A little history lesson. At first, it was discovered that NO2 depleted the ozone layer. And NO2 is naturally occurring in volcanic eruptions and in lightning, especially in the good old nitrogen cycle when it's fixing the N2 out of the atmosphere. So there's some naturally occurring things that destroy the ozone layer, but not at a rate that it can be undepleted. So it's at an equal rate of depleting and forming when it's just nature. It's us that make it a imbalanced rate. So what the first thing that we did was in the green revolution, these fertilizers. Fertilizers have NO2. That's one of the forms of nitrogen that plants like to uptake. And so the green revolution was partly responsible for the first part of the ozone layer depletion. Then we got more industrialized and we made the famous CFCs, chlorofluorocarbons. And those were in things like refrigerants, coolants, our AC devices, aerosol, propellants, fire protection, things like that. And then we also had these methyl bromides, which were pesticides we sprayed on our food to keep bugs away. So if you remember any chemistry, the periodic table shape's kind of like a castle. And in this seventh column, right here, are the halides. And we've got stuff like fluorine, chlorine, and bromine, all the enes, right? And they are the culprits. They are the ones that affect the formation of ozone in the stratosphere. And these are all chemicals we were using just to have our lives and our comforts, but we didn't realize that we were causing the ozone layer to get a big hole in it. So a little unfun fact, one chlorine molecule, one chlorine atom can destroy 100,000 ozone molecules. Just one. And just think how many we probably have in all of these chemicals and all of the stuff and all the products that we have. So it can be a big, huge problem. Okay, so why is it a problem? So remember our little natural cycle over here. O plus O2 gives us some ozone, and back and forth, goes both ways. Well, when the chlorofluorocarbons or the bromos, whichever, get involved, so the UV light will also break this CFC chemical, and this is a fluorine with some chlorine and some carbons, but it'll break off a chlorine atom, and this ozone molecule will naturally get rid of the O3 and it'll have an O2 and an O. So this O2 is looking for an O right there. This O2 is looking for an O, but instead of finding an O, it finds a chlorine. It finds a Cl. And so this unholy joining of molecules occurs, and we get this depletion because it should be an O3 happening, but we get this ClO instead, a chlorine oxygen combination, chloroxide. And so This will attach and it will prevent this little oxygen molecule from joining with an O2 molecule to make ozone. It doesn't get its chance. And then eventually the chlorine molecule will detach and it'll go look for another one. And the rate this happens is faster than the rate that the ozone rate occurs. So one chlorine molecule can visit a lot more single atom oxygens than a diatomic oxygen molecule can. This happens a lot slower. This happens faster. And so it can get to more of them and like infect more of them, so to speak. Okay, so this one's a little tricky. There are some things in nature that cause ozone depletion, and this is a little confusing, so I just copied it straight from the source so I don't say it wrong and you can read it and push pause and read it at your own leisure. But here's what happens. The ozone hole is a seasonal thing. We get a bigger ozone hole in the spring after a really cold winter. So like right now, we had a very cold winter in 2023. It is going to be a big ozone hole. And if you check Google, it is. It is very, very important to keep this straight. Depleting the ozone layer does not cause global warming. They're two totally different things. Now, some chemicals could be ozone hole depleters and greenhouse gases, but the ozone layer having a hole or not having a hole has nothing to do with global warming. That's a hard thing to keep straight. Okay, so this pretty picture down here, let's look. So again, the ozone hole is a seasonal thing. During the Antarctic winter, when the polar stratospheric clouds are widespread, here they are, chemical reactions convert less reactive forms of chlorine into large amounts of highly reactive forms. These highly reactive gases have such a weak hold on their chlorine atoms, they're only stable in the dark. So when the sun rises out of the southern hemisphere winter, sunlight degrades the reactive gases, releasing free radicals of chlorine. Remember that Cl is going to connect with the O. The single chlorine containing free radical can catalyze the destruction of thousands and thousands of ozone molecules. Ozone destruction usually peaks in mid-October. Ozone loss tapers off in late spring as the polar vortex weakens. Temperatures rise and fewer clouds are going to form. Ozone-rich air from low latitudes mixes back into the polar stratosphere and the ozone hole disappears until next spring. So this is all the technical stuff about it and why. This is the big idea here. Just know that the big ozone hole happens in the spring after a pretty cold winter, and it's seasonal. So we'll get a big hole and the hole will repair, and it's just kind of like, if you watch videos of it from NASA, it looks like it's just open, close, it's moving all the time. Okay, so what do we do to solve it? This Montreal Protocol. This is a big deal. This is a big piece of legislation. It's not legislation, I just lied to you. It's a protocol, it's an agreement. This is not a California law. This is not a U.S. EPA law. This is a agreement or a treaty the whole world agreed to do. And the big date was September 16th, so you can have like Happy Ozone Day on September 16th. But it's an agreement that we start phasing out all the bad chemicals that deplete the ozone. So we universally agreed on these chemicals that cause it, and we've left it open to add more chemicals. If science indicates, hey, these are ozone depleters too, we can add to this agreement to make it more up to date. So the big deal with this is it has improved our ozone depletion. And the ozone hole is actually improving right now. So we are on a good path, and hopefully we'll continue to do so. And we will be aware of what causes and doesn't cause the ozone hole to deplete. All right. One side note, we have found some alternative chemicals, and yes, they're ozone friendly, but they are greenhouse gases. So, and some of them are POPs, those persistent organic pollutants. So yay, we're saving the ozone layer, but boo, we are creating greenhouse gases that are trapping heat in our atmosphere and warming our planet. So we did good on one portion of it, but we are not doing so good on the other portion of it. So we always have to be careful what we do when we change and see if we're making it worse or causing some other thing to be a problem, which we did with these CFCs and these HCFs. So they don't have the chlorine or the fluorine in them, but they are still a problem. Yipes. Okay, so how does ozone protect human health? Well, again, it can increase skin cancer rates. It can cause cataracts, which leads to blindness. But again, we need some to have some vitamin D. Skin cancer, mole check. If you have any moles that look like this, check yourself because we don't want you to have skin cancer. So these are examples of what skin cancers can look like. And if you have weird shaped moles that have rough edges or are uneven, then you might want to go check with a dermatologist. Cataracts, that's when people have like that white pupil-y look, and that's from a cataract forming, and it can be caused from UV light interacting with you. Okay, some consequences. There's a whole bunch going on here. So if this ozone layer continues to deplete, letting ozone through, letting those UVBs and UVCs through, it can damage our food security. That can affect human health, human population. Economically, it can ruin crops, it can ruin structures, it can be a problem. So there's an economic problem and there's a health problem for that. It can damage ecosystems and ecosystem services. That's an environmental problem. Animals can be affected by the UVB and UVC radiation also, which in turn could affect the food web both on land and water. So that's going to cause environmental, economic, and human, and all of the problems. If plants are affected and they die, then the carbon sink is gone and the climate change will occur. We'll have global warming in some places and climate change in other places. UV radiation damages materials like wood and plastic and rubber, and that can affect the structural integrity of buildings, so that could be an economic consequence. So there are economic, environmental, and human health issues for all the ozone depletion. So it's all three. So know which ones cause which. Okay, that should give you a good overview of the ozone, and I hope you enjoyed.